Good morning. Good morning. Hello.
Hi. Beep boop.
Did you guys see the recording on YouTube yesterday? Anybody?
I didn't go on YouTube.
Did anybody? It's up there, and you know why? Because I switched in my settings to record to the Zoom cloud. I guess you get a little bit of free storage on there, just enough so that I could download it and upload it to YouTube.
Mr. Rosenthal?
Yes.
So, for the test is going to be like in the folder for us to look at during the entirety of the test taking session, right?
Yeah, but I mean, it doesn't need to be. You can just, when it opens up, you just download it as a PDF.
Right.
Then
Okay.
you have it on your computer. Then you don't need it. I would hope everybody does that in case Schoology goes down. Then you have it.
And you're going to post it at 9:50 again, 10 minutes before?
Approximately, yeah.
Okay.
I mean, I could post it right at 10, but, you know, I might have more people turning it in late. And I'll have some instructions in there. I want everybody to download Cam Scanner if they can, or if they have a scanner, they don't need to, so that everybody can upload it as one document. And with Cam Scanner, let me wait till everybody's in, or most people are in here before we talk about that. That's weird. I got rid of the waiting room, and yet Oliver got stuck in there. Okay. All right, you have one of the problems that we're going to be reviewing is already up on the board. This is the next one. This is slide 8 out of 16, just before the halfway mark.
Yay.
Yeah. I will be right back. I'm going to put this chair back in my kitchen.
Alan. Discord. No.
All right, guys, I love you.
We love you too, Mr. Rosenthal. Okay.
Bruh.
So weird, bro.
All right.
You know, right.
Getting posted on YouTube, Mr. Rosenthal.
Bruh.
Okay, if you have a scanner and you don't know how to make it one thing, download the app, Cam Scanner, for free.
I already have a cam scanner, a literal cam scanner.
That's great. I'm trying to help those that don't know what they're doing or don't know how to do it.
Oh, you have a lot of people then.
Can we just like go on our phone and take pictures of it and then send it in?
No, because when you do that, I get a bunch of different files, and it makes it really tedious for me to grade it when I have to open up different files. I'm really begging you, asking you, please, 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 get them all into one document. Cam Scanner does that. So if you use Cam Scanner, it will ask you to take separate pictures. And then it counts them, you know, and then however many pictures you take, that's how many pages your document is. And then you email it to yourself. Now it will ask you, do you want the collage option? You do not want the collage option. They'll ask to upgrade you to a paid one. I'm not asking you to do that. But don't do the collage one. But you just,
Mr.
this is for people that don't know and don't have Cam Scanner and don't know how to use it. Other than that, it's pretty easy to use. You just take a picture and then you can share or email it. So you choose to email it, and then you can email it to yourself and download it. And then you can upload it to Schoology. And it won't take a lot of time. I've been now putting documents in myself, doing it that way. Nice and easy.
And it also, since you
Sylvia, did you try to download
scanned it
Cam Scanner?
Yeah, and since
Why
it
can't you
scans it
download
all.
it?
Hmm?
Sylvia, why can you not download Cam Scanner? By the way, I don't need 100% of people to do it. I need most students to do it. So I need a collective effort. If I have to click between files for a few students, I can handle that. It's when all the students are not, when I only have a few students that have done the documents the way I need, it took me all of my spring break to do all the grading. So it's not acceptable. All right, if you guys make it very, and you know, some of the students had their tests out of order, different documents all over the place in different revisions. It was a nightmare. So not your fault, we were all learning. But now that we have learned, and I'm telling you now that I'm telling you how I want it, I expect it that way for it. If you cannot do it for some reason, then you can't. You don't even have to ask, what if I can't? There's no what, it's, if you can't do it, you can't. But I want you to try as hard as you can to make it easy for me, because you're just submitting yours. I'm grading 200 students' tests if you include all my geometry students who just took their chapter 12 test. Okay, so please, what I want you to do for Monday is have Cam Scanner, try it out first, test it today, see if you can get it to work where you can do multiple pages, take pictures. It will then, don't do collage. If it asks you to do collage, you will have to pay to upgrade it. You don't need that. By taking separate pictures, you can then email it or share. But you're going to want to email it to yourself. Then you can open up the email and download it onto your desktop, onto your computer. Once it's on your computer, you can upload it to Schoology. Okay?
Mr. Rosenthal?
Okay, so now I'm getting the question again. Could you just email photos to yourself and save it on Google Drive and then upload it? As long as that puts it into one document, Andrew.
Yeah.
If that puts it into one document, then yes, definitely. So it does not have to be Cam Scanner. It's the result that matters, not the method. You can use whatever method you want. I'm recommending one method that I know works. If there are other methods that work for you, what I want is one document in order, page 1, page 2, page 3, page 4. By the way, it helps if you can do the work right next to the problem. Then I don't have to go, but scrolling, I can do it pretty quickly. But if I have to look at page 1 and then I have to open up another document to get page 2 and then download it so that I can have them side by side, it's going to take me 10 minutes per student to grade. Whereas the student that puts it all in one document, it takes me 60 seconds to grade. 1 minute, so 10 times as much grading, 10 times the length and energy of grading. Please don't do that to me. Yeah.
I have a question about the answer key. So I just realized on my thing, you asked to do like a better answer key. So what should the answer key be like? Should we do like all of the problems and put that first and then put an answer key?
I'll tell you, ideally, I want you to print out the document
If we can't,
that I put on the PDF.
Yeah, okay. But
For some reason, if you don't have a printer, see if you can get if you have a broken printer, see if you can get that working by Monday. Now, for the very few of you that cannot print, then you're making, only for those few, you're going to make your answer key look like what the answer key looks like on the actual document, where it's over to the right and it's all in order. 1, 2, 3, 4, 5, straight down, so that when I'm grading, I can go boom, yes, 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 yes. This one I need to look at your work. And your work is over here, right next to it. Yes, that work makes sense for that answer. Boom, next one. There's the answer. That's right. This work makes sense for that answer. That's ideal. And then I scroll. I go on to page 2 by just scrolling down. There's page 2. Boom, 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 done. And I move on to the next person's test. Okay? But when I have half of page 1, or excuse me, sometimes it's half of page 3, that's the first file that you submitted. The work for that is on page, is like the 5th document you submitted. And then it's just a mess of documents out of order. I have to go and I have to click it, do a drag down menu. I don't know, you guys don't label what page is which, some of you, and even when you do, that page is not necessarily that page, right? And so then I have to find the work. Now I'm clicking through different documents and it's not even the work I'm looking for until I find it. Then I open that, it's just, that's what I went through last time. So you guys have to be more organized. All you have to do is worry about yourself. Remember, I have to grade everybody's. So please, one document where I can just scroll through your pages. Cam Scanner will do that. Andrew said that if you take pictures and put those in Google Docs, it looks like you're going to be able to then send it as one file, I think.
What do
Mr.
we
Rosenthal?
download Cam Scanner on?
I just did it on my phone. So I went on my phone. So here's Cam Scanner is this CS over here. See it?
Yep.
Okay. I just downloaded Cam Scanner. Okay.
Mhm.
Okay. So in there, they try to sell you other stuff. I just X that out.
I don't know.
Those
if
are the
it's just me,
documents
but
I've
the
done.
screen's really blurry.
The screen's really what? You don't
The
need to
screen's
see this
pretty
stuff.
blurry.
Well, I have a protector on and it's got glare on it. That's not important. Just look. You can see this blue button at the bottom. Right away, there's a blue camera button. It's so self-explanatory. You just hit that button and look what comes on. It's a camera. It's already ready to go. You just, you hold it over put it on the floor so that you don't have a weird background and get the right shot. And you do not need to do collage. One of them is collage. You don't need to do collage. You just do
download Schoology on your phone.
I just do batch. Okay, so batch. So I click, I scroll it to batch, and then I just start taking photos of each page. And when I do that, it keeps track of all my pages, and then at the end, it will allow me to email it. So let's see, let me just take a random picture. That picture shows up there, and it says 1, right? If I take another, it's still ready to take another picture. When I take another picture, it'll say 2. However many pages I take a picture of, right? And then when I'm done, then I can, let's see, I can click the picture. When I click the picture, now I can crop it. I can get it to just be what I want it to be. I crop it how I want. And then when you're done, you hit the check button. Okay. So there's the picture that I took. If it was multiple pages, you would see the multiple pages on there. Don't mess with and then down here, it says I can share, PDF preview, email. So I hit email, and look, I'm going to email it as a PDF right there, PDF. There it is, and everything looks good. I hit send. When I hit send, it's going to ask me who I want to send it to. And then I hit myself, and then I send it to myself, and then I get the email with it's all in one document.
Does that mean you're low?
There I went. There's your tutorial on Cam Scanner. It's really easy to use. If you have another method, that's fine. Okay, let's actually get to our review. Pull that back up. The number of kilograms Y in a measure varies directly as the number of pounds X. Okay?
So Y equals X.
No, Y equals KX. If something varies directly, then there's some scale factor that gets multiplied to X to get Y. It could be 1. If K is 1, then Y equals X, yes.
I
But
can't
K
read the
doesn't-
problem.
Yeah, I know, I'm reading it to you. You shouldn't have to because you have it printed out, right? Because these were all available on Schoology, right? Right? Or you have another computer you can look at it on. Or your computer.
I can
you
just
look- Yeah, or
I
print
can
it out.
probably
So
just switch.
you shouldn't be depending on my screen. If you can see it, then you can, great. If not, you still have this in front of you anyway. The number of kilograms Y in a measure varies directly as the number of pounds. There you go. If you want, by the way, you can put kilograms and pounds just so that you keep track of what Y is and what X is. Write a direct variation equation that can be used to convert pounds to kilograms. If 4.4 pounds is 2 kilograms, no problem. 2 kilograms goes for Y. K you don't know yet. And that's what happens when you have 4.4 pounds. That comes in here.
It's easy.
And I'm going to find out what K is by just dividing. Okay? So. Okay? And then you can use your calculator. 2 divided by 4.4.
0.45 vinculum.
Okay. So it looks like K is, yeah, like you said, is that. So then my equation is this. That's what you multiply to the amount of pounds to get the amount of kilograms.
Mr. Rosenthal?
Yes.
But aren't there 2.2 pounds in 1 kilogram? So if you have 1 kilogram.
Okay, so then you're solving a different one. So I'm going to do that in a different color. Now, how would I change the problem? The number of pounds varies directly. The number of pounds, Y, if that's pounds, varies directly as the number of kilograms, which is also true. If it's proportional one way, then it's proportional the other way. So now that's kilograms. All right, so now 4.4 pounds is here. Okay, there's K, and 2 kilograms would be the X. Now divide by 2, and there's your 2.2. K is 2.2. Now make your equation. Y is equal to 2.2x, where X is kilograms, right? So you take your kilograms and you multiply by 2.2, and that's how many pounds something is. But this problem is backwards. They're saying when you have a certain amount of pounds, how many kilograms is it? See, the order in which they say it determines what the units are going to stand for. See what I'm saying?
So this would be correct on the test.
This would be incorrect on the test because
Be
you're going the wrong order of what this is saying. This says Y is kilograms. So you have to do it this way, which is going to give you this division, which you may not like that division. This division is much easier, isn't it? Dividing by 2 and getting 2.2, that's easier.
Yeah.
But you have a calculator available, so it's no big deal, and you just write that.
So
You just have to deal with the discomfort of having something with a vinculum.
the equation you need to find out never mind. I got it.
Was it my daughter screaming in the background that changed your mind?
Huh? No. I was wondering what that sharp noise was.
Yes, it was sharp. Any questions about this problem? So you're going to set up your Y equals KX. You go in the order that they tell you. Y is kilograms. X is going to be pounds. And they tell you what they are later. 4.4 pounds, you just fill it in. 2 kilograms, fill it in. Solve for K. Rewrite your equation with the variables Y and X, where K is now solved here. Okay? That's your direct variation equation that can be used to convert pounds to kilograms. So now I can tell you how many pounds, you multiply it by this, and that's how many kilograms something's going to be. So if you all can do if you know how much you weigh on a scale in pounds, you multiply it by that, and that's how many kilos you weigh. All right, moving along. Let me shrink this just a bit. That'll do. Find the constant rate of change for the function shown in the table. You probably can see that nicely because it's large. Let me bring the screen up a tad. That table is pretty large. I know you guys can see the table. Okay, so find the constant rate of change for the function shown in the table and then predict the profit if 40 rings are sold. So you got two things you need to do. Don't try to do it all at once. Just do the first one. Find the constant rate of change first. Okay? So what is constant rate of change? It's slope. It's delta y over delta x. That's what you need to remember. That's what I'm testing you to see if you remember that. Constant rate of change is
Delta y over delta.
yeah, it's delta y over delta x. So look at your delta y. What is your delta y? Remember, delta is changing. It's changing. It's increasing by 15. So put positive 15. Delta x?
By 6. Increasing by
Positive
6.
6. And simplify. Divide by 3 on both top and bottom. Okay? If you want, you can leave it 5 over 2, or you can make it 2.5. That's what that is, 2.5. Okay? So there's your constant rate of change. You get credit for knowing that. All right? Now, write your equation. Is this direct variation?
Yes.
Right? If 40 rings are sold, right? Well, this is counting by 6s. 40 is not a multiple of 6. So they're trying to make it a little bit more difficult than just saying, well, I can just keep completing the table till I get to 40 rings. Well, you're not going to land right on 40 if you're getting multiples of 6. So they're wanting you to do this by equation. Go backwards to see if it's zeros, if it lands on 0, 0. You go back by 6, by 6, by 6, right? Or you could have done 15 over 6. That's the same as 30 over 12. That's the same as 40. So it is proportional. It's direct variation. All right? So it's just going to be y equals 2.5x. This is direct variation. And then x is how many rings are sold. So then you can just do 2.5 times whatever the amount of rings you sold. And that will give you your profit. So this is just 2.5 times 40. Okay, so that's 100. Your profit will be $100.
Like Mr. Rosenthal,
Mm-hmm.
and like in like an equation, like in a problem like this, you should know that if you sell 0 rings, you're gonna make $0 profit.
Yes, 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 absolutely. You guys are going to be well prepared for this test. I have a good feeling about this.
Mr. Rosenthal?
Mm-hmm.
So, can you back it up a little bit? I have one question.
About the last slide or
No,
this slide?
slide.
Okay.
So, where did that 40 come from?
They asked me,
Oh,
predict the profit if 40 rings are sold. Well, they don't have that in the chart. I could try to follow by multiples of 6, but your 40 is not a multiple of 6, so I'm going to use an equation.
oh, so you just take the rate of change and you multiply it by 40 to get. Okay.
Yeah, if you look, multiplying each of these by 2.5 gets you those answers. This is the equation. The profit is equal to 2.5 times the rings sold. Or you can say, you know how much it costs per ring, don't you?
Yeah.
Yeah.
$6.
No. 6 is the number of rings sold. The amount of money you made was that.
Oh.
So you look at the equation. $2. It's $2.50 per ring.
It's $2.
That's what your slope is. It's really your price that you're paying per item.
Okay. Okay. I see that. So you just find this. You just find the slope by simplifying delta y over delta x.
Yep.
Thank you, Mr. Rosenthal.
You betcha.
Mr. Rosenthal,
Mm-hmm.
how did you know what was the x and what was the y in this problem? Because it never says which one.
It's an XY table. I saw it as an XY table.
Oh, okay.
Okay. Now, if I made this the Y and that the X, could I still get it to work? Yes. It would change my slope and it would change the meaning. right? It would change the meaning of things. All right?
Yeah.
So my slope would be different, but it wouldn't mean the same thing. It wouldn't be $2.50 per ring, right? It would be a certain amount of rings per dollar is what it would mean. Okay? And then I would be counting how many dollars, which would then tell me how many rings I must have purchased. It would be doing it in a backwards order, but you would still get the same answer. You would still get a profit of $100. All right, moving along. All right, predict what happens to the graph of y equals 3x minus 5. I think I can up the size of this. Let's up this to 380. Predict what happens to the graph of y equals 3x minus 5 when the slope is changed to negative 8. So change m to negative 8. So I don't have to do any math here. You can draw a picture of what this might look like. You can sketch it if you want. What does this look like?
Just change the
Y-intercept.
the graph.
And it's steep. It's not a 45-degree angle. It's steeper than that.
Yeah.
Like that. Now, if I change that slope to a negative, remember,
It's gonna be a negatively.
it's going to go like this. It's going to go flatter, 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 0, down, 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 and down very steep. So, okay. So it's going to look like that and probably even steeper. Okay. Oops.
Mr. Rosenthal?
So hold on one second. So it says predict what happens to the graph. Okay. So now the graph of the line is going to decrease from left to right in value. That's how I might say that. And it will be steeper. It will make it steeper than it was. Steeper in the negative than it was in the positive. Okay? So those are different ways you can describe what happens to the graph. Yes, Everett.
So when it says change m to negative 8, you just literally just move it down to negative 8 instead of negative 5.
You're just taking, no, that was not the slope.
I know the slope is 3 over 1.
So I did not change this. See what happened? This line still goes through negative 5. You're basically changing the equation to this.
So you change the slope.
That's what it says. When the slope is changed, nothing else changed, just the slope is changed.
So it's y equals mx plus b. The m changes to 8. So then the
Negative 8.
The
negative 8 over 1. Okay.
So it's steeper and it's decreasing from left to right instead of increasing from left to right. Positively sloping lines, they increase their value as they go from left to right.
Mm-hmm.
Negatively sloping lines decrease in value as they go from left to right. So that's one way you can answer the question. Also, you want to mention that it gets steeper. Because 8 has more absolute value than 3. So that means it's going to decrease steeper than it was increasing.
Can you just say one more time how you would answer the question, like how you would explain the?
Yeah, I'm telling you verbally how I would do it. Verbally, I would say two things. I would say that the graph is now decreasing from left to right in value, whereas it was originally instead of increasing from left to right in value.
and it becomes steeper.
Yes, and it becomes steeper.
Mr. Rosenthal?
Mm-hmm.
Instead, I put, for my explanation, I put, the line will change into, a steep negative, it will change into a steep negatively sloping line.
Well, I mean, yeah, that's not as good because we already know it's turning into a negative slope. So you're not really saying much of what, in addition to what they're already giving you that it's negatively sloped. Yeah, we know that it's negatively sloped, but how does that, what does that look like is what they're asking you.
Yeah.
So I would just say the
They're
graph is
asking you.
decreasing.
They're asking you to understand, not just intuitively, oh, I get that that's negative, I get that that's positive. Can you articulate it in words? What does it mean when you're looking at my hand doing that? It means that the value is decreasing as you're moving from left to right. Right? The value is my up and down. What is the value up and down wise as I move to the right?
It's like time. It's like time is like X, and then
Yeah, as time goes by, is the total increasing or decreasing? So the value of the function, the value of the graph, the value of it is increasing or decreasing from left to right. By changing the slope from positive to negative, you are changing it from increasing in value from left to right to decreasing in value from left to right. And you're doing it, you're making it steeper. All right, that one is toast. We really beat that one. Okie doke. Oh, look at all this stuff here. Okay. The table shows the percent of teenagers aged 16 to 19 who received a driver's license from 1981 to 2004. 1981, 1985, that's 4 years apart.
We
These
can't
are
see the
5
table.
years apart. So they don't even count by the same amount. They're not counting by the same amount. From 1990 to 94, 4 years apart. 4 years apart. You guys don't.
Move the camera up.
Well, okay. Okay. Thank you. Thank you. So from 1981 to 2004, what this table is showing, I don't want to make it any smaller. The table shows the percent of teenagers. So those numbers are the percents of teenagers who received a driver's license. Okay, what was the rate of change from 1990 to 1994? This doesn't have a constant rate of change, if you notice. That's why this problem is confusing. I really need to make this bigger. So
We can do the equals, and then we can do y1 minus y2 divided by
make this larger.
x2.
Okay, if you notice, I know some of it's cut off, but if you notice here, it's jumping by different amounts of years. They're going to do that on purpose because they're not giving you a constant rate of change. But what they can do is say, what is the change between a set of years, right? And so here, they're saying between 1990 and 94, then guess what? The rest of the chart does not matter. We only care what happened between 1990 and 94. See that? So we can find the temporary rate of change between those years. Okay? So it's actually an easy problem that can be hard if it's confusing to you. That's why we have the review. Okay? So from 1990 to 94, this would be the delta x. Time is usually delta x. I'm going to actually put my delta y first. So it looks like it dropped 3% over a 4-year period. Okay, that's it.
Oh, I was pretty. I figured it looks complicated.
It looks complicated, and you have to get through all the mess of the problem to just, so it's, they tell you though, the words are telling you, what is the rate of change from that year to that year? So that should help. I mean, that should not be that confusing. You're just focusing in on what's happening between these 2 years.
Yeah, it just gives you like a bunch of like information to try to confuse you, right?
Everybody make a note right now that time is almost always the delta x. So
When is it?
So that I don't want you to put 4 over -3. I want you to put the time as the delta x. Even though it's on the top, it's actually going to be the denominator. Okay? By the way, look at what's happening. Fewer students over the years are getting their driver's license in their teenage when they are able to. In the first 3 years that they're eligible to, fewer students are actually doing that. I remember when I turned 16, I had an appointment at the DMV to do my driver's test on my birthday because it was such an exciting thing to be able to do that. And now society is changing with technology, and fewer kids are as.
We don't need to drive. There's Uber.
There are still many people. Yeah, and that's even more. You're going to see even a bigger drop off because of that. But there's still going to be a group of people that are super excited to drive themselves. Maybe you want to work for Uber, right? I wonder, you probably have to be a certain age anyway.
No.
All right, move. Are you calling me? Oh, okay. All right, let's see. I have this too large. I'm going to take this down to, let's call it 280 and see what's there. Okay, so we got that problem. Okay, now we're into systems, which is kind of fresh in our memory. So let me make this, let's make this 320. Oh, that's pretty good. Can you guys see the system? So they want us to solve this system by graphing. And I'll write the equation here, the two equations. First equation is 5x plus 3y equals negative 21. And I can quickly see they are in what form?
Standard.
They're in standard form. So I'm going to graph using intercepts. By the way, these all have a common factor of 2. Did you notice that? So if you want, you could divide everything by 2 to simplify it a bit. So I could write this as 2y minus 3x equals 5. That's optional. You don't have to do that. Okay? I don't want to confuse anybody. Okay, so what I want to do now is I want to gather my x and y intercepts by doing that for the red one. Okay, so when x is 0, plug it in. 5 times 0 is 0. This is now 0. 3 times something is negative 21. Oh, negative 7. There's my y-intercept. Now I'm going to find my x-intercept by making y 0. So when y is 0, I am on the x-axis. So 3 times 0 is 0. 5 times something is negative 21. Well, I can solve that by just dividing by 5. So it's negative 21 over 5.
Or 4.2.
Right. Now I don't want it this way because negative 21 over 5 is not as easy to understand where that is on a graph. So that is negative 4 1/5, or negative 4.2. Okay. So I'm going to convert this one into this one. Okay. There's the red one. Now I'm going to do the blue one. Yes.
Is the slope? I mean, are you adding negative 3?
No, I'm not doing it that way. I'm doing it this way. This is an alternative method that I use when I'm in standard form.
By graphing.
This is not in slope-intercept form, so I'm not using the slope and the y-intercept.
How do you slope?
I'm finding the x and y-intercept.
Slope intercept.
When it's solved for y. When it's solved for y.
Oh, God.
Okay, let me go to this blue one. I'm going to use mine that I reduced. You can always use this one. It's the same thing. All right, what happens when x is 0 and what happens when y is 0? When x is 0, negative 3 times 0 is 0. So I have 2y is equal to 5. Divide by 2. Y is 5 over 2, or 2.5. What happens when y is 0? I get negative 3x equals 5. I divide by negative 3, right? And I get negative 5 over 3, or negative 1 2/3.
Wait a second. Okay, wait. So you divided?
I solved the equation by plugging in x is 0. So I'll show you the whole thing.
5 times 0 is 0.
Not 5 times 0. 3 times 0.
But if x is 0, then why are you putting the y as 0?
That's x.
Okay, let's back it up to red to the first blue. What did you do to get it to turn into 2y minus 3x equals 5?
Okay, red and blue are two separate equations. I remember that came up yesterday. There are two separate. I did not get the second one from the first one. They're two separate lines on the graph. Okay? So I did them in two different colors to show you they are two different equations. Everything in blue, though, I got from blue. I got the second line of blue by dividing everything in the first line of blue by 2 just to make it make the numbers a little smaller. You don't have to. I mentioned that that is optional. Next, I made an XY table in which one case x is 0. I would then be able to plug in x like I'm doing now here and see what y has to be. Then you solve this for y, you get 2.5.
So what's the answer?
The answer to what? To the whole question, to the whole thing?
Yeah.
I'm not there yet. We have to wait until everybody's clear on where we are now.
Also, is this solving it by graphing or solving it with an x and y table? Yeah, but don't we have to actually graph the line to have it be solved by graphing?
Again, I have not finished the problem. I'm waiting to make sure everybody's with us at this time. So right now, we're still asking, how did I get to where I am now? So I'm not going to keep going until everybody's where we are.
So this is my final question. So you have net. So in the red equation, you substituted the x for 0. So now you just have yes, which neutralizes the 5, and then you have 3y. So you divide 3 by 3 and negative 21 by 3, and you get negative 7.
Yes.
So then you plug in negative 7. So
No. I'm done. Move on. Now what happens when y is 0? Now you go back to the beginning, and instead of making x 0, y is 0. Okay? Then you do the same thing. Then you have to divide by 5 by 5, and negative 21 divided by 5, which is what you see here. But that's negative 4 1/5.
But why don't you just write what negative 21 divided by 5 is?
I wanted to know what happens when y is 0, because when y is 0, my coordinate lies on the x-axis. I want to know where the x-intercept is. I am graphing by finding two specific locations, which you're going to see happen when I graph. I am finding the location of the y-intercept, and I am finding the location of the x-intercept. Those will give me 2 points, one on the y-axis and one on the x-axis. Then how many points determine a line?
2.
2. Once I have those 2 points, I can graph my line. So I am finding two specific locations that I can make a line through. One being the y-intercept of negative 7. The other one is the x-intercept of negative 4 1/5. How did I find negative 4 1/5? Well, I know ahead of time that when a coordinate is on the x-axis, the y-coordinate is 0. So I can locate it by putting y 0. When you put y 0, 3 times 0 is 0. It is neutralized. What's left is 5x equals negative 21. How do you solve 5x equals negative 21? You divide by 5 on both sides, giving you negative 21/5, which can then be put into a mixed number. That is all I can say about that.
Okay.
All right. So now I'm going to graph. Now,
Wait, Mr.
hold on one sec. The issue with this is that I tried to give you a problem that wasn't exactly the same. So when I did that, I was kind of in a rush. I gave you a problem that gave you fractional amounts. I don't think they're going to have you do a problem by graphing that gives you these fractional amounts. So on the actual test, these will probably be integer values. They will not be fractional values. So that will mean that you'll probably be able to find the answer exact by graphing much easier than what you're seeing me do now. I'm going to flip the screen down and I'm going to graph these two. Let's see. So I have to account for -7 and I need some stuff on the left. I need stuff on the left and up. Okay. So this is going to be a bottom left heavy graph. Hopefully that's going to work for me. 1, 2, 3, 4, 5, 6, 7. Okay, and then I'm going to have over here 1, 2, 3, 4, 5. And I need up here 3. 1, 2, 3. And there are no x coordinates that are to the right. So, but I might need them anyway. And this is going to be difficult. I may not get this accurate the way that this is, but I'm giving you how to do the problem. Okay, this is how you do it. Where is 0, -7? It's here. Where is -4 1/5, 0? It's about there. Okay. You can use a ruler on the test. Okay. Now, the blue one. The blue one is at 0, 2.5. Okay. The X-intercept is at -1 2/3, 0. So my intersection is going to happen somewhere over here. Okay. When you do it on your test, these will not be, I don't think that they're going to be fractional amounts. Where they cross, if you use a ruler, it should land on a whole, on integer values. Okay? I don't believe that they're going to give you solve by graphing and it lands on a non-integer value. That I would just say doesn't, I wouldn't even count that against you. Okay? So this appears that the answer is at -3, -2 about. It looks like my answer is at -3, -2. Now, of course, I would have to try those out. You would want to try them out. If this is -3, this would give me -15. If y was -2, this would give me -6. And they do add up to -21. Okay, so maybe that worked. And then if I plug it into this one, if x is -3, what's -3 times an x of -3 is +9. -2 times -2, -2 times +2 is -4. And when I add those together, I do get 5. So that actually, I did find it. That worked. Thank goodness. Okay, so that was my solution right there. -3, -2, and I got it by graphing. Questions?
Could you do it where you turn it into slope-intercept form?
Yes. You'll still have to graph. You cannot do this one by elimination or by substitution. You can do it by substitution or elimination algebraically to check the answer if you're having a rough time finding it. But you better graph those lines on your paper when it tells you to graph them. I better see accurate graphs. I'm not just looking for the solution when I grade this one. I'm looking to see that your lines are those red and blue lines. They should meet at that coordinate and they should be correct. Yes.
How would so I was trying to do it another way where you just swap the variables around and turn it into a y equals mx plus b equation. Can you just technically do it like that if you're graphing?
Yes, you can graph use and put them into slope-intercept form by solving them for y.
Okay, but
you're going to get the same line. You're going to get a y-intercept of 2.5 for the blue one. You're going to get a y-intercept of -7 for the red one when you do that. Your slope is going to be a fractional amount. Okay, and that would work. And then you're going to get this. All right, so when you graph this red line, you're probably going to graph this way. You're going to draw your line to connect them up there. When you do the blue one, you're probably going to do a point, and you're going to use the slope to get another point up here. And then you're going to graph, and then they're not going to meet over here. They're going to meet over here in quadrant 3. And you're going to have to see where that is. Use a ruler on that particular problem to make your line as accurate as you can. Questions?
So
We are running low on time, folks.
I was
Just
asking.
so you know. Anybody?
How much of the test will be graphing problems?
I don't know. That's not something we have time to answer now. Just make sure you know how to do it. Questions about this problem?
Do you suggest that we do it the way you did it?
Well, I did it this way because the way that I do it is the way that I suggest. Yes.
Okay.
Okay. All right. Let me move it up to up here, and let's go to slide 13 of 16. And we're getting close, but we are getting low on time. Okay. Solve the system. It doesn't tell you how. So if you happen to like graphing, you can do it that way. But I don't recommend it. So let me get this one up to like 500 so you guys can see it. Okay, so I'm going to do this algebraically, and it makes life easier when you know how to do it algebraically. Now, if one of them is solved for a variable, then you can use substitution. Look how they put this one. They're really trying to make you guys understand this. So the first one is in standard form. The second one is not in either form. This one is not in any form. It's in between forms. So you're going to need to manipulate a little bit. So negative 5x equals 3y plus 4. If you're trying to solve for one of the variables so that you can substitute, that's one thing you can do. But I see that either way, if I try to isolate y, I'm going to, in the end, have to divide by 3. These numbers are not, 3 is not going to go into these numbers. You're going to get fractions. Then you're going to substitute fractions and have to distribute with fractions and add and subtract fractions later. So I don't want to do that. So I'm going to go for standard form. What I'm going to do is I'm going to subtract 3y on both sides and watch what happens. I'm going to subtract 3y and it will be neutralized over here and it'll just leave you 4. And that's going to be beautiful with my red one. Watch what happens. Let me recopy my red one here. And let me add them. Left to left, right to right. This cancels out. This cancels out. You have nothing left over here. This one, when you add them, you get negative 17. And it's not true, right? Therefore, there are no solutions.
Wait, so you didn't need to do all of that work? You just, like, there were no solutions in the end?
Yeah, so another way I would have done it is to put them both in slope-intercept form or put them both in standard form.
So they're parallel lines?
They're parallel lines, yeah. If you put them both in slope-intercept form, you would see that they have the same slope, but they would have different y-intercepts. So they are parallel lines is what they are.
It's asking you it's asking you the exact same things as the last problem, right?
Yeah, it's solving the system, is getting the solution to the system.
So if you did it the way you did it last time, you would have found that it was no solutions as well?
Yeah, you would have gotten parallel lines and you would have realized, oh, these lines never touch.
Mm.
Okay.
So something you can do to see if it's no solutions or not is just like align them and then see if like it doesn't work.
Right. There was algebraically, you could get them into slope-intercept form, both of them, and just examine the two slopes and y-intercepts to see if they have the same slope and different y-intercepts, then they're parallel. Or just graph them and see it. So there's lots of ways to see.
Do you always add them at the end?
I add them if I'm using elimination to solve. I didn't know in the beginning I was going to get them to cancel out. If you cancel out both variables, right, then you get a 0 equals some other number and it's false, you're going to get no solutions.
So like on the question, like the test question, let's say it was, because you know how you make the reviews just like it, so it's going to be something like this.
It
So
could
we
be
would do
infinitely, what if it was 0 equals 0? Then it's infinitely many solutions. It could be that on the test. Or it can actually have a solution. It could be that you only eliminated the y's and then the x's that you still had some x's and positive or negative x's left equal 17, negative 17, and then you solve for x and plugged it back in to get the y. So it could be any of those situations. Okay.
Okay.
Anybody else? Okay, 3 more slides. All right, I'm going to shrink this down to, let's go 350. Let's go 370. Yeah. All right. This one is interesting. Find the value of b. Yeah. Let me pick it up. I'll pick it up. Find the value of b so that the slope of the line passing through the points -3, 7 and 5b is -3. So this one tests to see your understanding of how slope works. If you understand how slope is put together, then you have these 2 points, -3, 7, and point B is 5 little b. You're trying to get your slope to be -3. So you know that -3 has to equal your delta y over your delta x. If you know that, you should be able to test for that. You should be able to know exactly what you need b. That's not a 6, that's a b. You should know, you should be able to know what
17.
you should be able to know what that has to be in order to get this ratio to come out to -3. So your delta y is going to be your b minus 7. That's your distance between 7 and, I don't know if b is less than 7. I don't know if b is more than 7. If I do b minus 7, that always is the distance between them. Okay?
Over 8.
It could be negative or positive. I don't know. Okay? And then I want to do 5 minus -3. Don't do -3 minus 5 and then b minus. Don't go in different directions. If you do the second one minus the first one, then you have to do the second x minus the first x. You can't flop it. You're going to get the incorrect sign if you do that. Okay? Then you get b minus 7 over 5 plus 3 over 8 has to equal -3.
So then you multiply 8 times -3.
Okay, multiply both sides by 8 to get b minus 7. B minus 7 is equal to -24.
And then you add 7. And b equals -17.
That's it. And you're done.
Boom.
Where did the 8 go?
We multiplied it by the
multiplied it on both
-3.
sides. Or you could have treated it as a proportion and cross multiply, cross products. 1 times b minus 7 is b minus 7. 8 times -3 is -24, and their cross products are equal.
Okay.
Okay, and then add 7, not add -7, add 7, and you get -17. All right.
Can you just walk me through it one more time? I got kind of lost in the.
They gave you 2 coordinates with a slope that you're trying to get. Out of the 2 coordinates, one of them was an unknown, the y coordinate over there. So what you want to know, they want to see if you know how to use this formula. y2 minus y1 over x2 minus x1. That's what slope is. That's supposed to come out to -3. So you take your second y coordinate and subtract your first y coordinate, which is what I did here. y2, y1. Okay. Then on the denominator, I did my x2 minus x1. 5 minus -3 is what I did here.
You know that B was Y too because it's the second Y
Yeah.
that they gave you?
Yeah.
Okay.
Now I could have done y1 minus y2 as long as I do x1 minus x2. If I follow the same order, it will still give me the same answer. Okay? Traveling from one point to the other, it doesn't matter what direction I travel, the slope stays the same. Okay. We have 3 or 4 minutes to do the next 2 problems. Okay. Solve the system of equations by specifically substitution, it says. So we got our first, oh, look at this first one.
You need to move up the camera.
Oh, thanks. Look at this first one. 3x plus 3y equals 9. Divide
You
everything.
can divide by 3.
Yeah, x plus y equals 3. Right onto your paper. Second equation, y equals 5/6 x plus 4/9. Substitute. Okay, so here we go.
Add,
X
multiply.
plus y equals 3. Where did the y go here? I'm going to plug in this. 5/6 x plus 4/9. All right. Now, let's get into it. So this is 1x, so I'm going to make it 6/6, so I can add it to 5/6. So now I have 11/6 x plus 4/9 equals 3.
We can make.
What?
Never mind.
I can multiply
By the 3.
everything by 18, couldn't I? I do
Yeah.
not have to. It is optional. But if I multiply by the least common denominator,
3.
is 18. No, that's a factor of both of these. That's the GCF. The least common multiple of these two is 18, right? If I multiply by 18, it will eliminate the denominator. But you do not have to do that. You can just start subtracting 4/9 right now. Okay?
Dude.
All right, so I might clear out the denominator, but let's multiply everything by 18 then. Times 18, times 18, times 18. Okay, so that will make this 33x, because 3 times 11. This will cancel out and make a 2, so that'll be 8. And I think that's 54. Okay, subtract 8. And what does that give me? 46?
Yeah.
And I'm sorry, I made this like this quickly, so I didn't know it was going to be nasty like this. Unless I did something wrong. 3y, no, 5/6 4/9. All that looks right to me.
1.339 repeating.
Yeah, gross. Okay, so now you get this. Yeah, use your calculator if you need. So I get 46 over 33 for x. And then I'm going to plug that back in here. I guess I can just make this 3 here with the denominator of 33, right? Times by 33, so 99 over 33. Then I could subtract 46 from 99. Okay, so when I subtract 46 from 99, I get
53.
53. So y is equal to 53 over 33. There you go, now you got x and y. And you can express it in your answer key as a coordinate if you would like. Yours should come out to, I think it'll come out at least more nice, it'll be nicer than this. Okay?
Wait,
It's
so
11 and I'm going to get on to the next problem. I can go back to this if you want to stay during office hours. I do want to hit that last problem here.
Wait, I just have one question. You multiplied by 33 on both sides to get 99 over 33?
Yeah,
Yes.
Okay.
Not on both sides, on top and bottom.
on one.
Okay.
It's 33 over 33, which is 1, so.
Okay, last problem. We're going to go 5 minutes over here, folks. You know, I'm going to put this on YouTube. Hopefully, if the recording goes properly, if you can risk it, go for it. You can go, but I would stay. I'm not dismissing yet, but if, you know, you got to do what you got to do. This might take a few minutes. A cell phone data package from provider X is based on a monthly fee.
The camera a bit up.
Yeah, I'm sorry. This is another system problem. So a cell phone data package from provider X is based on a monthly fee of $20 plus 8 cents a minute. So I'm going to do this right now. Y is equal to 8 cents a minute, where X is the amount of minutes, not the provider, plus a $20 fee. I'm going to make my equation already. Okay, provider Y, and the X and the Y are there to confuse you. That's not the Y in my equation. Provider Y charges $15 a month for their data package plus 12 cents a minute. Okay, so they're both monthly fees. So that this is what the cost is a month. Y is the cost per month, and it's based on your fee plus the usage, the amount per minute. So my second equation is Y is equal to 12 cents a minute. So it's more expensive than that one per minute, but I only had to pay $15 to start. So you're going to see they're going to cross graphs. So even though this one was cheaper to start, it's got a steeper price, steeper slope. This is flatter, but it started up higher. So you're going to get this for the red. The blue one's going to start $5 lower down here, but it'll be steeper charge per minute. After a certain amount of minutes, they'll be the same price. So at what number of minutes of internet use will the monthly fees be the same? They're asking you to find the solution to the system. No problem.
You make them equal each other?
Yes, because they're both solved for Y. You're going to substitute for that Y. You're going to substitute that. So you're going to get 0.0.
Oh, that makes it so much easier.
Yeah.
Because then it's just 5 equals 0.04x. So it's 125 minutes.
Yeah, so let's just finish this. Okay, so I'm going to get x's on the right, actually, by subtracting 0.08x. And since I'm neutralizing that here and leaving them over here, I'm going to neutralize the 15 over here and put it over here. So what is that, 4 cents? That's a difference of 4 cents a minute. So this one is going to gain 4 cents a minute on it. Right? And it's got to make up for the $5 difference. So basically you're finding out how many minutes at that extra 4 cents that you're paying, how many minutes do you have to do to make up that $5? That's all you're really doing. So you're dividing by 4 cents. So you're seeing how many times 4 cents goes into $5. You could do that on a calculator, but 4 cents will go into $1 25 times. So 25 times, so it's going to be 125. 125. So at 125 minutes, the plans will be the same. Dismissed. We are now on office hours.
Bye.
Please, cam scanner, please show up early. Look in that Zoom test folder on Monday.
Would we have graphed it for this question?
I just have a scanner. Is that okay?
The what?
Would we have graphed it for this question?
You could have graphed it. Didn't ask you to.
Okay.
It says at what number. And remember, I copied this question the way that you're going to see it. So this is how I would do it on the test.
How do you get 125?
5 divided by 0.04. I thought of it as $5 divided by 4 cents. 25 times 4 cents makes $1. Okay, or 4 times 25 cents, same thing, makes $1, right? But I need to make $5, so 25 times 5 is 125. Or put it in a calculator, you'll see 5 divided by 0.04 is 25.
Mr. Rosenthal?
Yes.
Could you go back to the problem before?
Anybody else have a question with this one before I erase it? Then I'll go back to the problem before.
Can you just,
Yeah, I need
okay. Yeah, I need help on this one and then the one before. So I just got confused on this one.
It
And
equals 12.5.
This one has a monthly fee of $20 and 8 cents per minute. So that explains the cost. The monthly cost of this would be the monthly fee plus the minutes that you use. This one had a monthly fee of
but it
50.
says like, it says that from provider X, and is X like,
No, it's just there to confuse you.
yeah, because I got confused because I thought X was like
No,
the thing we were trying to, okay.
nope.
That's weird.
Because
Okay.
that X has nothing to do with anything. The name of the provider doesn't matter.
Mr.
Okay,
Russell,
okay.
Yes,
I put it in a calculator and it said it equals 12.5.
no, then you.
Oh, wait, no, I
Yes.
put in 0.4, not 0.0.
Yeah, you put in point.
I got just a scanner because I don't have a phone. Is that okay?
Yep.
Okay.
Why? Remember what it's not the method that matters.
Okay.
It's the outcome. The
Does it
outcome
work?
needs to be, the outcome, I really, really would like the outcome to be that I can view one document with several pages in the document.
I think I can
If
do that.
your scanner achieves that, then I don't care how you do that. If your scanner
Okay.
does, that is wonderful.
Okay.
All right. Any other questions about this last problem? No? Then I'm going to go back to the problem before. Oh, thank you. I got a note from my children. Thank you. What is it? It is Daddy lifting weights. That's great. Thank you. They drew me a picture of me on the bench press. That's me. And that's me lift the weights that I lift. And that is drawn to scale. Just kidding.
Drawn to scale, does that mean the weights are like 1 ounce each?
No, if it's drawn to scale, that means that if that was my actual size, that's how big the weights are that I'm actually lifting.
So are they made of foam?
This is not me saying drawn to scale, by the way, is not the same as saying actual size. That's different, something totally different. Okay.
Same thing.
All right. No, they're totally different. Okay. So the first equation is x plus y equals 3, because I divide everything by 3. The second equation is this mean, nasty, like that. So really the problem, wanting to see this problem, I'm wondering if it's because you don't know how to do it or you don't know how to deal with the fractions.
No,
Both.
this part I know.
Well, what about all the other systems? You don't have a question of those. Why this one? I don't think it's both.
I didn't get how you.
It's not both. But anyway, what do you want to know about this?
Just the part where it's 46 over 33 plus y equals 3 over 1 or 3.
Let me get back to it then. Okay, so it's x plus y in the red equals 3. Y is equal to, at the point of intersection, 5, 6x plus 4 ninths. You can simplify to collect these like terms. 1x plus 5, 6x is 11, 6x. Plus 4 ninths equals 3. Let's say I don't get rid of the denominator. Subtract 4 ninths on both sides. So 11 6x is equal to 3 minus 4 ninths is 2 and 5 ninths. Okay? Or if you make 3 into 9, if you make it into 27 ninths, you can do 27 minus 4 is 23 ninths. It's just what this is. This is gives you that. Okay? I'm assuming you can do 3 minus 4 ninths. Okay? 2 and 5 ninths. Okay? Now I multiply by the reciprocal. and I have something in common here as a 3. And I get 46 over 33. X is 46 over 33. Okay. Then I plug it back in the red. 46 over 33 plus the y is equal to 3. I'm going to make 99 over 33. That is 3. Just so I can have a common denominator. When I subtract that on both sides, I get 53 over 33.
Oh. So I thought when you multiplied the 3 by 33, we had to do it on the other side. So
Okay, so there's different ways to account for things with different properties. I did not use the multiplication property of equality. What I did is this. I multiplied by 1. That's the identity property.
Right.
That means that I didn't change the value. I don't need to multiply the left-hand side by 1, do I?
No, you
Because
don't.
of the identity property I used instead. Now, what I also know is that that 1 just has to be equal in value to 1, which means if I multiply by 33 over 33, that is 1. Then that changes it to 99 over 33 without me having to do anything on the left.
Got it. Okay. Thank you.
Welcome. Other questions?
Bye, Mr. Rosenthal. Thank you.
Bye. Have a great weekend.
Thank you.
Get some rest.
So all I had was that in the beginning, you divided everything by 3 to get x plus y equals 3, right? And then you substituted y for the equation.
I substituted this blue part here into the y for red.
Yeah, okay. And so then after that, you like merged the x and the 5.
Yeah, we call that collecting like terms or adding like terms, combining like terms. Here.
Okay, and so then you got 11 over 6x and plus 4 over 9. And then you subtracted the 4 over 9 from
on both sides.
On both sides. And then you ended up with 11 over 6x equals 23 over 9, right?
Correct.
And then you multiplied by the reciprocal on both sides to cancel out that to just get x equals 46 over 33.
You betcha.
Okay. Thank you. I just needed a recap on it.
Yeah, recaps are great.
Thank you, Mr. Rosenthal.
You
Thank
bet.
you.
Okay.
Mr. Rosenthal.
Yes, sir.
So I'm doing the quadratic formula like by.
Oh wait, Jasper. Before we do that, does anybody have any review questions they need to do again or need to see, and then we can do some algebra. Going once. Going twice. I see we have a little bit of an algebra audience going on here. I think the 4 of you in here are here for algebra. Is that right? Jasper, Jennifer, Jonathan, and the other Jasper? All right, so let's do some algebra. Jasper, go ahead. Take it away.
So I'm completing the square in the quadratic formula. So I subtract.
Oh, yes. Okay, so let's get that up here. A, X.
And I'm a bit because I subtracted C on both sides.
Yes.
Okay, so I'm going to subtract C on both sides to get that.
And then I divided by A on all.
Okay, on the left and on the right, you divide by A.
Yeah.
So when you divide that by A, it gets rid of the A.
Mm-hmm.
Then I divide this by A, and then I divide this by A.
And then I was completing the square, so I did B over A times 1/2. And then I got.
I'm going to do that off on the side here.
Okay. And I got B over 2A. And then I squared
And that's,
that.
so B over 2A is half of that middle term. So that when you do B over 2A plus B over 2A, what does that equal to? It equals to 2B over 2A, which the 2's cancel and just gives you B over A.
Mm-hmm.
Okay, so yeah, so that is half of b over a is b over 2a.
And
So
then
it's kind of cool that you learned that, oh, if I just stick a 2 right there, that's half.
yeah.
Okay, so you have that value that when you add it to itself gives you b over a, but on the end here, that b over 2a has to multiply to itself, right?
You would have to, I think I squared it.
Yes, so let's see
And
what
then I
that
got
b over 2a times b over 2a is
And
b
then I-
squared over
Over
4a squared.
Oh, it's.
See that? And that, so that
So
value,
why is it 4a squared?
2a times 2a?
Oh yeah, 2a, 2. Okay.
Yeah, when you add fractions, you don't change the denominator. You just write it over one common denominator. But when you multiply fractions, you actually multiply the denominators.
Okay, so
So this is the value you need to add to both sides.
yeah. Let me write that. Let me write down like
Sure, take your time.
it's b squared over 4a squared. And then you would add that to both sides, which would be x squared plus ba times x plus b squared over 4a squared equals negative c over a plus b squared over 4a squared.
Yep. Now,
You would factor?
yes, because you have a square, and that value here that represents 2 times the root of that times the root of that is what that is.
Mm-hmm. So it's like, so in the middle term, half of that to the half of that
So
squared
it's the square root of this
square root.
plus the square root of that, which
Okay.
is b over 2a, which is what you got here before you squared it, right?
Mm-hmm.
Squared is how you factor that. Is equal to over here. Now I'm going to use the commutative property to switch places here. Not only that, I want to write this with a common denominator. So this has an a. How do I get it to be 4a squared? I'm going to need to multiply by 4a over 4a. So that's going to give me now 4ac over 4a squared. Okay, which I can then rewrite everything with a common denominator. So I have here x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared.
So it
Okay.
would be x.
Now take the square root of both sides.
And then that would,
But you have to be very careful at this point. When you take the square root of both sides, you are taking the square root of an unknown. Do you know what the value is underneath my hand?
no.
No, you don't know it. So when you take the square root of an unknown squared, what's happening here is that if I had a negative and I squared it, it would give me the same thing as if I had a positive.
So it would have to be the absolute value.
Yeah, but we're going to skip the absolute value step. We're going to say that it's just plus or minus over on the other side. So x plus b over 2a is equal to plus or minus b squared minus 4ac. And actually, the denominator, you can take the square root.
So
It's 2a. So I don't need it as a denominator anymore.
yeah, because yeah, you can tell that,
okay?
but you can't tell the top value.
Yep. And then finally, if I subtract b over 2a, it already has the common denominator. So I can write it all over. So I could write, when I subtract it, it'll be negative b plus or minus the square root of b squared minus 4ac all over the
So
common
you would
2a. And
you
that
subtract b over 2a on both sides.
yeah, and I express it as negative b plus or minus. I mean,
Because the
it could be
denominators
minus
are the
over-
same.
Yeah, you could have put minus b over here, but you've seen this before, right?
Yeah.
That's the quadratic formula. But you can see the quadratic formula just comes from completing the square. And then all of a sudden you can fill these in with numbers instead of a, b, and c. You can have numbers here. and then you plug those numbers in here, and guess what? You now know what X is.
Yeah.
And if you know what X is, guess what? You can plug it back in and find out what that is when it's not 0.
Yeah.
That's what X is when Y is 0.
Oh. Yeah.
So when Y is 0, where are you? You're on the X-axis. And because it's one is plus and the other's minus, it's in 2 locations. All right? It could be in 1 location if the curve just touches the X-axis and then comes back up. If it only touches in one place, so that the axis that X-axis is tangent to the parabola, then what you're going to get is you're going to get 0 in here. What happens when you have plus or minus 0? Then adding and subtracting, you're adding and subtracting 0 gives you the same answer.
It's the identity.
So you will only have 1 root instead of 2. So if you wanted to, you could find out how many roots you have by just taking this part under the square root. If what's inside the square root is 0, you're only going to have 1 root. That means that the parabola touches the X-axis at 1 spot only. If it's a positive value in here, then you're adding a positive value and subtracting a positive value are going to have to give you 2 separate answers. That means it's going to cross through and come back. And then if you get a negative inside of here, that's impossible. When do we remember what was happening in our systems of equations when you get a false statement? Something that can't be true, a contradiction. It means that the 2 lines never touched, right? Well, what does it mean in this case? It means that the parabola maybe turned, it doesn't touch. It turned back up before it ever got there. Or if it was below and coming up, it turned around before it ever touched it. Never touches the X-axis. And what that looks like is when you do this calculation, you get a negative inside of here.
Oh. Thank you, Mr. Rosenthal. That was very fun.
All right, very good.
I understand it a lot better now.
Excellent. And then knowing it in this form, when you go back to it, when they have numbers there, it puts it into perspective.
Cool. Thank you.
All right, is that it?
Yep.
All right, have a wonderful weekend.
You too.
All right. Bye, guys.
Bye.
See you later. I'm going to end the video.
Bye, Mr.
Mr. Rosenthal.
Bye, guys.
Bye.
Bye.
Bye.